Hi guys. Yes, another lesson. Are you guys ready? Last lesson was quite long, wasn't it? I don't think this lesson is going to be that long, but I will try to cover section 12 and I will make another video for section 13. Okay, that's a bit shorter lesson. Yeah, but this video will cover section 12. Okay, we continue graphing it. All we need to do in this section, okay, can you write this down? Following features should be labeled. First, x-intercept if they exist. Okay? 2, y-intercept. Basically, you get x and y-intercept. How do we know how many x-intercept do we have? Using determinant b squared minus 4ac, isn't it? Bigger than 0, how many do we have? 2. Equal 0, 1, smaller than 0, no exist. Okay, no real number exists. If I draw that, 2, the case we have 2, either like this, I have 1 and 2, yeah, or not something like that, 1 and 2. We can see 2 there, or 1. Yep, we have 1. We have 1. See that? Non-exist. Something like this. There is no x-intercept. Okay? So remember the determinant. We done it a couple of lessons before, right? And if there any x-intercept exists, how do we know? X-intercept is same as linear. When what is 0? Y equals 0. Good guys, try to communicate. Y-intercept when what is 0? X equals 0. Excellent. I'm happy to teach you guys. 3. Axis of symmetry for turning points. Okay, I mean when we get the turning points x and y, obviously that x is axis of symmetry, isn't it? Yeah. So for example, I'll draw that turning point. That's the turning point. X, y, isn't it? Yep. So that will be x equals something. Let's say this is 4, then that is axis of symmetry, isn't it? Yeah. And in this book, they actually add one more thing. Let's say this is 2 and 4. Axis of symmetry is between those two, isn't it? So all they need to do, getting the average, is between 2 and 4. When I say between, it's like I'm getting average. How do we get the average? Plus 2 numbers divided by how many numbers there? 2. 6 over 2, 3. That's another way I can get when you know only these 2 numbers. Yeah? 3. I mean, that could happen from here as well. Minus 8, minus 4, minus 8, minus 4, divided by 2, so minus 6. I can get that. However, when you had something like this, 1 and minus 1, well, in this case 0, I should give you another example. I'll give you this, like this. Yeah, pass minus 1 and 3. Let's think about that. Sorry, I just drew it again. minus 1, and 3. 3 minus 1 divided by 2, 2, 2, 1, so it's 1. Yeah, well, that works in this case. What about this? Four minus 4. You add it, 0. 0 divided by 2. 0, isn't it? Sounds okay? Yep, that's another way you can get that. Alright. So I cover. So x-intercept, y-intercept, good. Axis of symmetry, good. I'm just covering page 61 and 62. Yes, I did turning point. Up. Oh, no, I didn't do that. So turning point. How can we get the turning point? For example, I can make, if we have y equals ax squared plus bx plus c, yeah, all I need to do, make that 2 completing the square or turning point form, isn't it? Y equals ax minus h squared plus k. I can use anything there. Yeah. So the turning point was h and k. That's what we did last class, wasn't it? Yeah. Another way we can do is x turning point equals, from here, I can use the form directly, minus b over 2a. Y turning point equals c minus b squared over 4a. So turning point is going to be minus b to a, yeah, c minus b squared plus 4a. You can use that directly as well from this polynomial form. Okay, you don't have to change it, but sometimes that's easier. So you need to be able to do both ways. Sounds good? Yeah. I will give you one example. Okay, let's go here. I will do example 2. Yeah. That example 2. Let's go there. Example 2. Y equals x squared plus 6x plus 5. Yeah. I'll just get the turning point. Okay. In this case, y equals x squared plus half of 6, 3. Oh, oops. Square. Okay. Minus 3, 3, 9 plus 5 equals x plus 3 squared minus 4. So I got turning point form. Okay, vertex form or power form. And then minus it and minus 4. So it's minus 3 and minus 4, isn't it? So that's one way I can get. Or I can just use that straight away. What is A here? 1. What is B? 6. C? 5. Yeah? And then all I need to do, x turning point equals minus B 2 times A minus 6 over 2 minus 3. Y turning point equals, still use the same thing, C 5 minus B squared 36. 4 times A is 1, which is 4. Okay? And 5 minus 9, isn't it? Minus 4. So I have minus 3 minus 4. Turning point x and y. So I get the exactly same answer. Whatever works. Yeah, whatever works. No, it's not really difficult. So you need to remember those formula, and you can just use turning point form either way. So I just cover example 2. Okay. oh, 4 turning point parts, yeah. I will continue that example 2 here. So in this case, hold on. I'll come back. Okay, I'll come back. I'll just do example 1 first, and I'll come back to this. So let's continue example 1. Did I cover everything? Yeah, I think so. Yeah. Example 1. Y equals x squared minus 16. They said sketch. Okay, how many things we need to cover? Remember, x-intercept, y-intercept. Okay, x-intercept exists, and then turning point, and axis of symmetry. I'll just write down any short form I can write down. No, just axis of symmetry. I'll just write down short way. You have to write down the whole thing. Let's do one by one. Before we're doing it, always, I'll just think about this. Just draw roughly, okay? So we actually know what's going on. X squared is this, and they move how much? Minus 16 to where? Y vertically, isn't it? Minus 16. Minus 16. So now I have graph like this. So I know y-intercept is minus 16. Well, didn't have to draw even. And I have 2 x-intercepts. Well, at least I have basic information. So y-intercept is when x equals 0. I'll just solve it algebraically as well. When x is 0, y equals 0 squared minus 16. 0 squared is 0. Therefore, y equals 16. So y-intercept is minus 16. Minus 16. That's easy enough, isn't it? Yep. X-intercept when y equals 0. When y equals 0, or through drawing, you know there's 2 x-intercept exist, or you can use determinant as well. Okay, you can prove it. B squared minus 4ac bigger than 0. Then you know the 2 x-intercept exist, or 2 solutions, I can say, same way. Y equals 0. So here, y equals 0 equals x squared minus 16. 16 equals x squared. Therefore, x equals 4 times 4, 16. Or minus 4 times minus 4, 16. Okay, so that will be 4, that will be minus 4. Okay, so we get x-intercept and y-intercept, and turning point here, x is 0, y is minus 16. 0 and minus 16. That's easy enough. We're just getting the point. We don't have to even go further in this case. Axis of symmetry is where x exists. So x equals 0. Done that. Simple enough. And question 2. Question 2. When we solve it, rather than using A, B, C, the formula, I'll probably just use turning point form straight away. X plus 3 square minus 4. I already done it here, isn't it? Yeah. So I'll use that. And then I get turning point. Turning point equals minus 3 and minus 4. Hooray, I get that. And based on that, I can go. This is positive, so it looks like this. 1, a equals 1. And then minus 3 and minus 4 here, so I can draw it this way. It's rough drawing, so I'm not sure that will go to negative or positive. We'll figure out here, okay? So I know at least that there will be two existing x-intercepts. So I know that two x-intercept, I know that, that's the information I can get from rough drawing, yeah? So we get the turning point here, and we'll just go y-intercept first. Y-intercept is when x equals 0, so y equals x squared plus 6x plus 5, 0 squared plus 6 times 0 plus 5, 0, 0, so y equals 5. Therefore, oh, I didn't really draw well, didn't I? So that should look like minus 3, minus 4, sorry, minus 3, so something like this. So that should be 5. Looks okay? Yep. Oh, was rough drawing, okay? It was rough drawing. And then let's go x-intercept. X-intercept is when y equals 0. Yeah, I'm keep doing it. I'm sure you know now. And y equals 0. 0 equals x squared plus 6x plus 5. Okay? Factorize it. 5 times 1 times makes 5. And then when we add it, 6, good. So x plus 5, x plus 1. Yeah, makes 0. So when x is 0, when x equals minus 5, or when x is minus 1. So minus 5, minus 1. Okay? When x is minus 5 and minus 1, y equals what? 0. That's why we got two intercept points there. And I can prove it. B squared minus 4ac. Discriminant is bigger than 0. You can try it from this form. Okay? Yeah. Also, I show you how to use formula. Isn't it? Yep. All you need to do, just figure out what is A, B, C and plug it in. To getting turning point, you can use that as well. So I really expect you're able to do both way. So just cover example 1 and 2. Example 3. Okay, let's go. Sketch. Example 3, where is it? Sketch the graph of y equals minus 2x squared minus x plus 3, showing any intercepts, if that exists, yeah, and turning point. So all you need to do, getting turning point and intercepts, isn't it? And well, in this case, look, this is minus 2. It's not 1 coefficient of x squared. So I'll probably use, rather than going to turning point form, I will just use formula. That probably makes much easier. So in this case, A equals minus 2, B equals minus 1, C equals 3. Isn't it? Yep. And then turning point form, X TP turning point equals minus B over 2A. Y TP equals C minus B squared over 4A. You can find that from reference book. Yeah. I think you can get that. So I'll let you do it. Yeah. And when we do that, roughly is minus. So you will get something, turning point, isn't it? So in this case, when you solve it, I get turning point is minus 1 over 4 and 25 over 8. Just plugged in. But B is -1, A is -2, C is 3. Just plug in the numbers. Okay, so that's turning point. So TP equals -1/4, 25/8. Okay, that's the point, turning point. So let's go -1/4, 25/8. It's just rough drawing. That's the turning point. And let's look at that. Is that positive or negative? It's a negative, isn't it? Positive, negative. Negative, minus, is it, dilation is 2, so it's a bit narrower, something like that. So I'm going and plug in here. So it will look like that. Again, that's rough drawing, so we'll go and figure out. But the information I can get is, yes, I have intercepts here. Good. So let's get the that y-intercept. Y-intercept when x equals 0. So y equals -2, 0 squared minus 0 plus 3, all gone, 3. So that's 3, isn't it? Yeah. And x-intercept is what? When y equals 0. So in this case, 0 equals -2x squared minus x plus 3, isn't it? Yep, and then you figure out, only option I can do is 2, 1, and then 3, 1. However, when you crossed it, they actually get negative number, so give negative to bigger number. -2, oh no, hold on. Oh no, when times it, I have to do it, because when I do 3 and 1 will be the bigger number, so I have to put negative here. So -3 plus 2, which is -1, that will be make -1. So I get 2x plus 3 minus 1x minus x plus 1. So 2x plus 3 minus x plus 1 equals 0. Therefore, 2x plus 3 equals 0, or minus x plus 1 equals 0. Yeah? 2x equals -3, x equals -3/2. Or minus x equals -1, x equals 1. So they're 2. So here, x is 1. Your drawing was pretty okay then. And -3/2. Good. So I actually cover y-intercept, x-intercept, good, and turning point here. So I need to indicate that -1/4, -25/8. You indicate that as well. Then that's completing sketch. Sounds okay? So don't forget, you need to write down turning point. Sometimes they may ask you to do axis of symmetry, which is x equals -1/4, and then x-intercept and y-intercept. X-intercept is when y equals 0, and y-intercept when x equals 0. So sounds okay. And then example 4. You can do that, isn't it? You can do it. And when I look at it, which one is easier to do it? What are you going to use it? It's still -2 here, isn't it? Rather than coefficient 1. So just use formula. Formula here. Okay? So can you do that? I'll give you a bit of time. I'll just write down solutions here. So I'll give you time to do that. Okay. I assume you've done it. You can pause it and do it. Yeah. And you have this solution 1. You can find that from Canvas. You all have solution. Yeah. So I'll just go through x-intercept and y-intercept. And they said there are no x-intercept, which means determinant is smaller than 0. Yeah. And all they done. So what do they do is look like that. Do I need to explain it? No, it should be fine, isn't it? But when I approach this question, I probably get turning point first, rather than getting x or y intercept. Because when you get the turning point, you can draw it. In this case, we use, did I use it? Yep. Using the formula, you get the turning point x and y. That was the turning point, wasn't it? So all I need to do, 1/4 and minus 55/8 minus 55/8. So that's the turning point, isn't it? And then what you need to do, look at it. That's negative. This. So I'll have something like that. And then you can realize it. Do we have any x-intercept? No. So you don't need to get it. You can write it down. Yeah, there's no x-intercept. And then all I need to do, just write down that turning points and getting y-intercept when x equals 0. That's all you need to do. So I recommend, go and get the turning point first. And then draw roughly. Then you will see the equidistance of x-intercept. Okay, and next one. Sketch, same thing, I think you're able to do that. So, can you do that using when A is 3, B is 6, C is -1, yeah, polynomial form, and then you use turning point a little bit there. Well, before getting turning point, yeah, you know what to do. Use formula and then draw turning point. Draw, rough drawing, and then there's an x-intercept and y-intercept. X-intercept when y equals 0, y-intercept when x equals 0. The number can be slightly more complex, but that's all. Okay, you're able to do that, and solution is here. All good? Okay. One more thing. Domain and range. Domain is all about what? X. Range is y. Domain, range. Yeah, I talked about that already. Just go through. Okay, that does not include the point. We done that, wasn't it? Exclude. When we have this, include points. We done that before. So I'll move on. Next question. Sketch the graph of the function y equals, they already done it for you. This question could be y equals, let's expand that, x squared, -1. Yeah? Or this. Either way, depends on. Maybe I'll solve this one for you guys. Yeah. Because this one has domain and range. This is the must know question. Okay. I can give you this or that. Well, that makes much easier though, isn't it? Or what about I'll let you do this first? Yeah? You can try that. I mean, we learn about domain and range, so you can try. I'll give you some minutes first, okay? And then I will solve it. Okay. I assume you paused it and done it. Okay. I'll continue that. This one will look like what? This, isn't it? Y. So x squared minus 1. Or from here, you can get x-intercept and y-intercept. Look at that. Y equals x plus 1, x minus 1. Let's get x-intercept here. Okay? When y equals 0, 0 equals x plus 1, x minus 1. That's easy enough, isn't it? Yeah. And therefore, x equals minus 1 or 1, minus 1 and 1. You can get that. Each intercepts here. Yeah. And from here, I can get that's minus 1 as well. Or you can do y-intercept is when x equals 0. You can use several different ways. When x equals 0, y equals 0 plus 1, 0 minus 1, 1 minus 1, minus 1. Therefore, y-intercept is minus 1. So you can, all I need to do, those 3 points I know, and that is positive, isn't it? Because x times x will give you x squared, which is positive, like this. So I know this one looks like positive graph. So that's the only possibility I have. Okay? Sounds good? However, now I'm going to use this to draw that. They said x, which is what? Domain. X is a real number, and what does that mean? Exclude minus 1. So x is between minus 1 and 3. Okay? However, I include 3, but I don't include minus 1. So in this case, I can draw this, exclude 1. I can use what? Empty dot. Remember that? Yeah. So empty dot. Follow that. And pass 1, minus 1 and 1. Continue till 3. Okay. And then till 3. I don't know what. Yeah. Does it make sense? Yeah. And they said show its intercept, which I done it here, which is 1, minus 1, and 0. And this is 1 and 0. Done it. And state is domain and range. So I need to go and check it here. When x is 3, what do we have? When x is 3, y is, all I need to do, just plug in here as well, or here. I'll just do it here. I mean, either way you can do it. 3, 3, 9 minus 1, therefore is 8. 3 and 8. Sounds good? Yep. So, domain x is a real number, minus 1 and 3, which is already there. Based on that, what I get is range y is a real number -1 and 8. Oh. Yes, correct. Was -1. Y x exists between these, isn't it? Which is domain. Y exists between these, which is range. Yep. The highest number we get is 8. The lowest range we can get is -1. Sounds okay? Yep. And in this case, actually, that didn't do that well. That include, yeah, and this one also include, isn't it? Yeah, what should include both. Sounds good? Okay. Anything? All right. I'll pause here, and then next video I'll continue section 13.